Good morning, everyone, and thank you for the opportunity to present today. In this project, I developed a machine learning solution to help ABC Bank improve its credit card approval progress. The key goals was not only to build an accurate predictive model, but also to ensure that the system followed responsible AI principles, including fairness, transparency, and regulatory compliance. Today, I will briefly walk through the modeling approach, this fairness evolution and explainability techniques we use, and the overall business value of the system. Currently, many credit card applications were still reviewed manually by analysts. While this approach allowed human judgment, it also introduced several challenges. This progress can be very slow, labor-intensive, and inconsistent, especially when banks reserve thousands of applications. In addition, manual decision-making sometimes introduce unintentional bias, which may create applicants' campaigns and reputation risks. So the goal of this project was to build a machine learning project or model that supports credit-approved decisions will ensure fairness and transparency. The database used in this project contain about 9,700 historical credit card applicants. It indicates variables such as applicant income, age, employment history, historic housing status, and family information. The target variable indicates whether the application can approve or rejected. Understanding this feature allow us to identify the patterns that influence credit approval decisions. This module progress followed a standard machine learning workflow. First, we perform data processing, including encoding categorical variables and standardizing numerical features. And next, we address class imbalance using an SMOTE, which ensure that the model does not become biased toward the majority class. We then trained on multiple machine learning module, including logistic regression, random forest, SGBoost, light GBM, and natural networks. Using multiple modules allowed us to compare performance and select the most appropriate way. The module were evaluated using metrics such as accuracy, precision, record, and ROCCAUC, which are currently used in credit risk modeling. Among all the test model, Light GBM showed the strongest performance. The ROC curve demonstrates that the module can efficiently distinguish between approved and rejected applications. We also analyze the learning curve to ensure the model generalizes well and does not suffer from significant overfitting. From business perspective, this means the model can perform reliably when evaluating new applications. In financial decision system, fairness is extremely important. To evaluate fairness, we contribute a gender-based fairness analysis. Especially, we calculate approval rate separated for male and female applicants and compare the results. The analysis shows that approval rate between genders were relatively balanced suggests that the module does not exhibit significant gender bias. This type of fairness is moderately important to ensure applicants will fair leading regulations and to maintain public trust. Another key requirement for financial model is explainability. Banks must be able to explain their decisions to regulatory or sometimes to the customers. To support this, we implement several explainability techniques. First, we analyze feature importance, which identify these variables and that most influence approval decisions. Second, we use SHAP values, which provide a global view of how different features impact predictions. Finally, we apply LIME, which explained individual predictions. This means the bank can understand actually why this a specific application was approved or rejected. Together, these tools ensure that the model remains transparent and interpretable. Overall, this solution provides several key business benefits. First is improve operational efficiency by automating large portions of approved progress. Second, it improves decision consistency across applications. Third, the reliable AI framework ensure that decisions remain fair, transparent, and compliant with regulations. These combinations of predictive accuracy and responsible AI practice enabled the bank to adopt data-driven decision-making while minimize on the regulatory risks. In summary, this project demonstrates how machine learning can support credit card approved decision while maintain the fairness, transparency, and able to translate to the customer. By integrating predictive modeling with responsible AI practice, banks can improve efficient, strengthen applicants, and build greater trust with these customers. Thank you for your time.